learning goals today. I can describe this shape and center of a distribution. I can describe the variability of a data set. 6 SPA2 and 3. So shapes, the way we can look at this, we can draw a curve, a line over the shape. And the way we tell, or the way I always remember, the way we say which direction it's going, this one's to the left, is where the tail is. So I see the tail as over here. I'll highlight it for you. The tail, oh, you can't really see that. Let's go yellow. Is over here, and that makes it skewed left. So if I were to draw a line over this next one, I have a big hump and then a tail that goes off to the right. If we look at the tail, that's how I remember the tail tells me what direction it is skewed. And the final one, if I draw a line over it, it is symmetric, meaning that it's very similar on the right side as it is on the left. With data, it's not going to always be exact, but it's more of a trend. So draw a curve along the top of the graph to show the shape of the data. Draw a vertical line at the center of the data. Write a statement about the shape and center. So if I were to draw, after I draw the line, I can see that it's pretty much in the center. So we would say the shape is symmetric. Now it asks me to draw a line through the center and write a statement about the center as well. And it seems that if I were to fold this in half, if my drawing was better, it looks like the center is in the center. So I would say that the data is in the center. Okay, we have a box plot. We learned a little bit about those the other day. And when I draw this from end to end, this shape seems to be skewed left because the tail is on the left. If I were to draw a line through the center of my hump, I can see the center is on the right side. Consider the following distributions of times it takes 6 students to get to school in the morning and go home from school in the afternoon. So first thing we want to do is draw a dot plot for these. So I have an 11. Now that I've created the dot plot, I'm going to draw the curve over the data. I can draw a line through the center, basically, for the morning. This curve on the afternoon is going to look a little bit different. I can see that the one in the afternoon is skewed left. The morning, I believe, is symmetric. What is the mean time to get from home to school in the morning for these 6 students? So we learned how to find the mean, so I'm going to add, and that equals 84. I have 6 data points, so I will divide by 6, and I get 14 minutes. I'm going to do the same thing for the next one because it wants to know how long it takes to get home from school to home. That also equals 84. I divide it by 6, and I get 14 minutes. For which distribution does the mean give an accurate indicator of a typical time? Explain your answer. So let's look at that. So in the morning, we have 11, 12, 14, 14, 16, 17. In the afternoon, we go all the way from 6 to 19. So which distribution do you think the mean shows a better picture of how long it takes? So I would say morning. Because all the times are clustered around that 14. They're close. And we can see that with this graph up here, how it's symmetric. And the center is in the center, which is what will give us a good mean. This graph down for the time to get home is very skewed and spread out. And sometimes the mean isn't the best way to show one center for our data. And these are the things that we'll look at with distribution. And we'll look to determine which measure of center we should use to sum it all up. Okay, no you try it question. Just make sure you have your notes all done.